All right. So, hello and welcome everyone. So, we are live right now. I hope I'm audible and visible to all of you. Please confirm your presence by saying some yes or no in the live chat, and also share these videos among your friends and relatives and let them know that we are live and we are going to discuss the chapter of or the concept of area under the curve. Right. Please let everybody of your friends, your juniors, everyone know of this particular lecture that we are live at this particular channel, and today we're going to discuss about another sets of questions, and we're going to look into the different aspects of how we can use the change of variables, and also how we can simplify our given curve or to find the area under the curve with respect to the x or the y axis, right? So we will see those particular things in detail in this today's lecture, right? I hope you are all ready to start. So let's get started, right? So today, as we start, we're going to discuss first of all about the concept of area bounded by two or more curves, right? So first of all, let me start with area under two or more curves, right? So let me first of all discuss about the area under two or more curves, right? So what do you basically means by area under two or more curves? Let's try to analyze and see over here, right? So if I have, let us say I have two function, sorry, let me change the thickness. So if I have two function, let us say the first function is basically f of x, and the second function is basically g of x. Okay, let us say I have these two function f of x and g of x. Okay, I have these two function f of x and g of x over here. These are the two curves, right? And I want to find that what is the area bounded between the lines between x equals to a to x equals to b. Okay, so I am only bothered about calculating what is the area bounded between these two curves from the line x equals to a to x equals to b, right? So in order to deal with this question, how we can solve it, so let us first of all try to analyze what does this graphically means. Okay, so if I try to draw the curve of both the functions over here, so let us say this is my first function. Okay, let us say this is my first function from x equals to a to x equals to b. This is my first function, y is equal to f of x. Okay, and let us say this is my second function, let us say any arbitrary function like this is my second function, y is equal to g of x, right? And I want to find what is the area bounded by these two curves, right? So I am only interested what is the area which is enclosed in between these two curves within these lines x equals to a to x equals to b, right? So in order to find out this particular area, what I'm going to do is that it's very simple concept is that I'm going to simply first of all, so let me take some different color. First of all, I'm going to find out this entire area, that is bounded by the f of x with the x-axis, right? So once I find this particular area, and then I'm going to find this particular stretch of area, right? So if I find out the area, so the required area, this is my required area, let us say some A, this is my required area. So in order to find this required area, what I'm going to do is that, first of all, I'm going to find from x equals to A to x equals to B, I'm going to find what is the area bounded by the function f of x dx, right? And then subtract it from that part of the area which is bounded by g of x, right? So this is something that I'm going to do over here. Okay, this is something that I'm going to do over here, right? And we can combine this, and I can write the effective area as going from x equals to a to x equals to b for the function f of x minus g of x, and we'll put a mod of it, right? Now why I'm putting a mod of it, because to ensure that whatever part I'm calculating is the positive one, right? Because I am more concerned about calculating the magnitude of the area, right? So this is something that I have already discussed in my basic lecture. So if you are new to this particular channel, please go back to the playlist and watch the lectures from the beginning, right? So we have already started this particular concept of area under the curve already in my previous classes, right? So please watch the previous lecture before you come for this particular lecture over here. Okay, I hope this is clear to all of you. Is this clear to all of you? Please let me know in the live chat. Is this clear? Is this clear for all of you? Please let me know the live chat. Is this clear? All right. So once we understand this concept, now we are basically ready to solve any types of question that can be given over here, right? Now, please note that why I'm putting this mod over here, because sometimes it might also happen that the curve is something like this. Okay. That is, my f of x is curve is like a decreasing curve and my g of x is curved like an increasing curve. So somewhere it is going to intersect, right? So let us say this particular point is x equals to c, where it is intersecting, and again I need to find the area from a to b. So in this case, for this particular part of the area, it is going to be f of x minus g of x, and for this part of the area, it is going to be equals to g of x minus f of x. Okay, so please note that depending upon what is basically the sign, so this particular function is y is equal to f of x, and this particular function is basically equal to y is equal to g of x, right? So once we have these two concepts and idea clear, then we can solve any types of questions that can come to us, right? Now, I'm also going to explain you one more concept. Please note that whenever you see this kinds of question of the area bounded by two curves, please try to apply your judgmental senses of basically knowing that which part of the area I am trying to calculate, right? So please try to first of all figure out from the graph or from the graphical approach that which part of the area I'm trying to calculate, right? So once you are clear with that, then you can solve any types of question, okay? Then you don't need to just think and decide how why the mod is basically positive and why the inside part is negative. You don't need to decide, right? So we will see how we will solve with the questions also, right? So, and one more concept that I want to explain to all of you is that let us say i am I'm going to find the area bounded by the curve. Let us say I have something curved like this, right? Let us say some curve like this. Okay, I'm trying to draw as much as fancy of curve over here, right? And this is b. So I'm going to find the area. Let us say sometimes the curve is easier. Sometimes let us say I have a curve like this. Let me draw some a nice curve, not a fancy curve. Let us say the curve is something like this, right? Okay, so I have to find out, and this point is not b, this particular point, let me say it is b, right? Sometimes it is also essential that, let us say this is a very complex function as y is equal to f of x. Okay, this is a complex function, okay, and this is not very easy to integrate in the first go. Okay, it is a complex function. Okay, I will give you example, but please note what I'm trying to explain, right? I am having y is equal to f of x as some complex form of function f of x, such that when you are trying to integrate with respect to dx between, let us say I am interested to find the area of this particular area, right? Let us say I am trying to find out this particular area. Okay, I hope this is setting is clear, right? So I am trying to find out this particular area, right? Now, when I try to find out this particular area, so in order to find out this particular area, I am basically going to do integration from 0 to x equals to b for the function f of x dx, right? But what I note is that now since f of x is a complex function, the integration of this particular function becomes tedious to me, right? But I observe one more interesting part over here is that when I take the inverse of this, when I take the inverse of this particular function, let us say the inverse of this function x equal to g of y. When I take the inverse of this function x equals to g of y, where g is basically nothing but inverse of f. Okay, g is nothing but the inverse of f. So when I try to find out the inverse of this function, f of x, I see it basically becomes g of y, and g of y is a simpler form. Okay, and g of y becomes a very simpler form to integrate, right? So when I have y is equal to f of x, it is difficult to integrate, but what I see is that when I take the inverse of it, it is easier to integrate. that basically makes me to conclusion that it is not always. So what I can do over here is that instead of integrating with respect to dx, I can also integrate by taking my strips, like this. I can also integrate by taking my small strips like this, and then integrate between the limit from from y is equal to 0. So this is also y is equal to 0, and let us say this y is equal to some d. Okay, y is equal to 0 to y is equal to some d. So when I integrate in this particular axis with respect to the y axis, I again get the same area, right? Is this clear? So what I'm trying to say that sometimes getting the area with respect to dx x-axis might be difficult. So sometimes making this particular strip and then finding the area in this manner might be difficult. So what we observe is that the inverse of that particular function is easier. So when I see the inverse of that particular function is easier to integrate, I will easily inverse that particular function, and instead of finding the area with respect to dx, I will do it with respect to the y-axis, right? So therefore, my ultimate area can also be given as integration. Now here the limit will go in terms of y. The limit will be given in terms of y, that is y going from 0 to y to d, right? Y equal to d, y going from y is equal to 0 to y is equal to d, right? For the function g of y dy. Okay, for the function g of y dy, and this will also give me my required area. Right? I hope this idea is clear. So it is not always necessary that in order to find out the area, we have to always find it with respect to the x-axis, right? You can have flexibility to change between what you want to do, right? So please note this and keep this idea in your mind so that you can solve questions easily, right? So yeah, gaming hub, what doubt you have, please let me know. Gaming hub, please tell me your doubt. Is this idea clear or not? Gaming hub, please tell me your doubt. Okay, I think he's gone. Okay, okay, let's proceed with the questions. Okay, I think he has no doubt. He's just okay. So let's proceed with the class and let's try to see one simple example question. Okay, so the question that I'm trying to explain. So let us say I have a simple question, that is find the area between the region x equals to half to x equals to 2. Okay, x equals to half to x equals to 2 between between the curve between the curve between the curve y is equal to natural log of x, between the curve y is equal to natural log of x and y is equal to 2 to the power x. Okay, between the curve y is equal to natural log of x and y is equal to 2 to the power x. Okay, so I have basically to find out the area, find the area find the area going from within the region. Okay, in the region in the region going from x equals to half to x equals to 2, bounded between these two curves, y is equal to natural log of x and y is equal to 2 to the power x, right? So first of all, when I have these kinds of question where you have to find the area bounded by two curves, the first and foremost thing that you need to perform is that first try to plot or draw the curve of that particular problem, right? So let me try to draw the functions. So I know it is pretty simple functions over here. It is simply, so first of all, I'm drawing for the curve y is equal to natural log of x, right? So I know the natural log of x, if the base is positive, so here it is e, which is a positive number, it is 2.71. It is a irrational number, so I'm only telling it up till 2.71 something something. So it is basically like this, right? It is basically like this, where at x equals to 1, it is equal to 0, but we have to go from x equals to half to x equals to 2, right? So and if I plot the function y is equal to 2 to the power x, so this is an exponential curve and something like this. This is an increasing function like this, right? Okay, this is an increasing function y is equal to 2 to the power x, right? So I am there to find the area that is bounded in between these two lines. x equals to half to this particular and between this curve, right? So my ultimate area is this particular area. Okay, so this is my ultimate area that I'm going to find it out. So again, what I'm going to do is that now I can look into this particular problem and see that y is equal to 2 to the power x is larger or is higher than natural log of x, right? So what I'm going to do is that in order to find this particular area, I'm going to integrate from x equals to half to x equals to 2, and it will be 2 to the power x minus natural log of x and then I will have dx, right? So this is going to be my required area, right? So if I try to integrate this, my area is going to simply come out as 2 to the power x divided by natural log of 2 minus x. So integration on log x is x log x minus x, right? So I hope you recall these results from by parts, right? You just simply do it this question by parts. Okay, for anyone who doesn't follow, I'm writing over here. Please try to apply the by parts. Okay, and if you haven't learned the methods of integration, please, it's my utmost request, please go back to the previous lectures. Okay, we have already discussed the indefinite integral, definite integral on this particular channel itself, and all those lectures are basically for your preparation for your JEE mains and advanced examination. Okay, so please watch those content before you're coming to this class, right? So from here, and the limit of the integration is going from x equals to half to x equals to 2. Now I know, please be patient. Please be patient when you are putting the limits of the integral. It is not always the case that you will have the lower limit equal to 0 and it will be easy just by putting the upper limit, right? So please be careful about it. Okay, sometimes also be careful when you have the lower limit also 0. Exponential e to the power x function or 2 to the power x function at x equal to 0 gives you the answer as 1. So people tend to forget this because they see 0 is there and it will be 0, so minus 0, and that's how they write the answer. So I'm basically pinpointing out that these are the points where students tend to make mistakes. Okay, throughout my experience, I'm trying to tell you that these are the points where students try to take mistakes. So please avoid doing those mistakes. Okay, so please try to avoid doing those mistakes there, right? So please don't do those kinds of silly mistakes. Okay, and please be cautious when you're putting these limits, right? So once you put this limit, the answer to this question is going to be equal to the area is finally going to equal to 4 minus root 2 divided by natural log of 2 minus 5 upon 2 natural log of 2, 5 upon 2 natural log of 2 plus 3 by 2 plus 3 by 2. So this is going to be the ultimate area, right? So please try to see whether you are getting this answer or not. Please check whether you are getting this answer or not. Every one of you, please check whether you are getting this answer or not. Please check whether you are getting the answer or not. Then we will proceed with the next problem. Okay. If you have any question, please let me know in the live chat. Any questions, any issues, please let me know in the live chat. Okay. Are you all getting this answer? Are you all getting this answer? Please let me know in the live chat. Just tell me yes or no. Just let me know yes or no in the live chat so that I can understand and we can proceed with the next problems. Okay. Is that clear? Also, another quick announcement for all of you is that we have already started our one-on-one online maths tuition, right? So if you are interested in joining the tuition classes where you want to study at the uh, freedom of your staying at your home and just preparing from your home by online means, okay, and you want to prepare on one-on-one where you basically will sit with the teacher and you will discuss your questions and your queries or your doubts and you will understand from the faculty, so you can always contact us on the number that is given in the description box of this particular live session. Also you can find the number floating in the live chat. Okay, so please contact us on this particular number to get access to the one-on-one batches. Okay, the batches is basically already started, so if don't be late guy, okay, just start as early as possible so that you can clear and finish up the syllabus at the proper timing. Okay, so the link is basically there in the description as well as in the live chat. Okay, so I think every one of you are getting this answer, so let's proceed with the upcoming questions. Okay, now there can be multiple sets of questions saying that they will be given in terms of functions which is bounded between two different functions, and then you have to predict which part of the function they are trying to talk about, and then you have to take the intersection of all that given region, and then you have to go for the area, right? So let me take on some examples to basically illustrate what I'm trying to mean. A simple example. So let me try to take a simple example. This question number 2. So here we have to find the area between the curve is basically given as, instead of giving you the curve equation, it is giving you the inequality. This is y is greater than square root of x. Okay, y is greater than square root of x, and another inequality is given as x square plus y square is less than of 2. Okay, so you have to find out the area between this, I mean between common area. Okay, so you have to find out the common area. You have to find out the common area, right? So to find out the common area between this inequality y greater than square root of x and this inequality x square plus y square is less than 2. X square plus y square is less than 2. So you have to find out the common area between this particular region. Right. So whenever you see these kinds of question, the best way again to proceed is by plotting the curve. Okay. So please first of all try to plot the curve of this particular or the inequality region, okay, or the common region that is bounded by this inequality, right? So what I can do is that the y is greater than or equal to square root of x, that is my first inequality, and the second inequality is basically given as x square plus y square is less than 2, right? So if I combine these two inequality, I will definitely get the region which is common in between these two curves, right? So how will I solve this question then? Now already we have discussed that in order to get the bound of the inequality, first of all, plot the curve corresponding to the equality, right? Okay, so I will first of all plot the first curve, and then I will try to figure out that what is the inequality region. So if I see the first curve, it is y is equal to square root of x, or y square is equal to x, which is a parabola, right? And square root function is there, so the negative part won't exist, so it is something like this. And the second curve, if you look over here, it is basically a curve of the circle, right? So I'm trying to draw the part of the circle which is in the first quadrant. So it is over here, it is will be root 2, right? It is root 2. Over here is also root 2. That is 0 comma root 2, and this is root 2 comma 0, right? This. Okay. And then we have this particular curve which is a parabola, y is equal to square root of x, right? So then if I observe this particular situation carefully, what I see is that I have to find this particular area. I have to find the area which is common in between the two curves, right? So this is my inequality region. Okay, so from the inequality region, so in the first inequality, if you look at the first inequality, it is basically talking about the region which is upper of this particular curve, which is to the top of this particular curve. And if I look into this particular second inequality, it is talking about the region which is inside the circle, inside the circle. So outside the parabola and inside the circle is, this is the common region. Okay, this is the common region. So now in order to find out this particular area, I have to first of all find this particular point till which I have to find the area, right? So what I'm going to do is that simply I'm just going to solve these two equations. So x square, and in place of y square I'll put x and is equal to, so from here I'll get x square plus x plus minus 2 is equal to 0. From here I'll get two roots. X square plus 2x minus 2 is equal to 0, and x plus 2 and x minus 1 it will be the root. So over here I'll get x equals to 1 is a point of intersection, minus 2 is a point of intersection, is not possible, right? So over here x equals to 1 is going to be the point of intersection. So therefore when I try to find out the area, when I try to find out the required area, so my required area is going from 0 to 1. The upper curve is basically a circle, and it will be square root of 2 minus x squared minus, and the lower curve will be square root of x, right? Square root of x dx. So this is something that I have to integrate from the limit x equals to 0 to 1. And once I solve this integration, the area is going to come out as, so you can try to do this, the answer will be coming out as half plus pi by 4, half plus pi by 4 minus 2 by 3, or if you simplify this, is going to be pi by 4 minus 1 upon 6, which is easy because you can also get this easily because it's a circle and another is a parabola, right? A standard curve. What you're going to do is that you can You can solve this by integration also, right? And you can also do it by different method by taking the half 1/4 the area of the circle and then subtracting this part of the area, right? This part of the area. So that is also a complex one. Okay, don't worry. This is the best and the easiest solution over there, right? I hope this is clear to all of you. This particular answer is clear to all of you. Are you all getting the same answer? Please let me know. Are you all getting the same answer? Okay. So if you're someone who is going to study, please study. Otherwise, just don't follow the hearts. Okay. Anyways, so there are some, always there are some people who will basically going to talk bad about everyone, right? Okay. Okay. Are you able to understand this? Any more questions? Is this clear to all of you? Is this clear to all of you? Are you having this answer? Please let me know in the live chat. Are you all getting the same answer? Are you all getting the same answer? Please let me know in the live chat. Is this clear to all of you? Is this part clear to all of you? Right. If this part is clear, now I want to give you one homework problem for all of you. Please try to solve. Please try to solve this homework problem. The question is, the question is, let let the function f of x, let the function b of x be defined as maximum of these three functions, maximum of sin x, cos x, and half. Okay. Let f of x be defined as the maximum of sin x, cos x, and half. Okay, and half. Then you have to find the, then find the find the area under the curve, area under the curve y is equal to f of x, y is equal to f of x between x equals to 0 to x equals to 2 pi. Okay, and y axis. Okay, or I should rather write x axis, y axis, and x equals to 2 pi. Okay, I think you can understand pretty much, right? So this is a question that you need to find out, and you try to solve this question because there is one more thing, that is maximum function, right? So there are three functions over here mentioned. I have to find out that particular region which is maximum over here, right? So it will be not be a simple straight function. You have to find out that in which region or which interval of x you're going to see which of the following is a maximum function, right? So let us say in the first interval sin x is maximum, so you will put sin x. In second interval cos x is maximum, so you will put cos x, right? So in that manner, you have to first plot the curve of this function and then you have to find out the area, right? So please try to solve this question. This is going to be a really interesting problem, and let me know the answer in the comment section of this particular lecture. I hope this is clear to all of you. Please take a screenshot of this question. Hello shorts video. Okay, so please try to take the screenshot of this question and try to solve this question and let me know the answer in the live chat. Okay, or maybe in the next class. Okay, so and if you're into this particular channel, please subscribe to the channel. Okay, so every day you can see that on this particular channel we are coming live not only with concepts of maths but physics, chemistry. Even we have our own channel for biology preparation. So those who are preparing for NEET, they can follow that particular channel of Tutee Learning NEET. Okay, so that particular channel every night from 10 p.m. you're having the lectures of biology. right? So please follow those lectures as well if you're preparing for NEET examination. Okay, and if you're preparing for JEE or competitive examination and you want to have a scheduled preparation for your examination, please follow these lectures. And if you want to take one-on-one online classes, please contact us on the number that is given in the description box. Okay, so I am letting you know the number. If you have any more questions regarding any queries regarding your questions or preparation, please contact me on this particular number. Okay, so please contact me on this particular number. Okay, so you can connect with me and my team on this particular number to ask me any question of how to prepare for IIT JEE examination or any other competitive examination at 10+2 level. Okay, so with this, I take a leave and we conclude the session over here. And in the next class, we're going to solve more example questions, especially from JEE Mains and advanced examination from this particular topic of area under the curve. And with that, we are pretty much done with the chapter of area under the curve. And with that, we are going to also start with the next particular topic that is going to be differential equation. I hope you are pretty much excited for the next chapter. So see you again in my next class. All right, bye bye.